Hello everyone, I am Professor Sachin Gurav, working as Assistant Professor in Mechanical Engineering Department in Binole Singhad College of Engineering, Solapur. I am having 12 years of experience and I have completed my ME Design. Today we are going to discuss radiation topic. First we will define what is meant by radiation. Radiation heat transfer is defined as the transfer of energy across a system boundary by means of an electromagnetic mechanism which is caused solely by a temperature difference. So, radiation takes place by electromagnetic waves. The energy which a radiating surface releases is not continuous, but it is in the form of successive and separate discrete packet or quanta of energy called as photons. Whatever the energy we receive from sun on the earth, it is due to radiation. Now we will see some important terms which are used in radiation. First one is total emissive power. It is shown by capital E. It is defined as the total amount of radiation emitted by a body per unit time per unit area. Monochromatic emissive power E lambda, capital E lambda. It is defined as the rate of energy radiated per unit area of the surface per unit wavelength. Now the next term is emissivity. Emissivity epsilon, it is shown as epsilon. It is also defined as the ratio of emissive power of any body to the emissive power of a black body of equal temperatures. So emissivity epsilon is equal to E upon EB, where E is emissive power of surface to the emissive power of a black body. For a black body, emissivity is 1 and for white body, emissivity is 0. Irradiation. It is shown by capital G. It is defined as the total incident radiation on a surface from all directions per unit time and per unit area of surface, denoted as G, and its unit is watt per meter square. Now we will see some important terms: absorptivity, reflectivity and transmittivity. When incident radiation G, also called as irradiation, impinges on a surface, a part of this energy is reflected back, shown as GR, comma, a part is transmitted through GT, it is shown as GT, and the remainder is absorbed, represented as GA, depending upon characteristic of the body as shown in the figure. So in the figure, a body is receiving incident radiation G, a part of which will be absorbed, part of which will be reflected, and remaining part will be transmitted. By using the conservation principle, the total energy, which is G incident on the body, is equal to GA plus GR plus GT. GA is nothing but it is absorptivity, GR it is reflectivity, and G tau it is transmittivity. Dividing both sides by G, we get GA upon G plus GR upon G plus G tau upon G is equal to G upon G is equal to 1. The term GA upon G is known as absorptivity and it is represented by alpha. GR upon G is the term it is represented as reflectivity rho, and GT upon G it is represented by tau, that is transmittivity. For black body, alpha is equal to 1, rho is equal to 0 and tau is equal to 0. For opaque body, tau is equal to 0 and alpha plus rho is equal to 1, no radiation is transmitted through the opaque body. And for white body, rho is equal to 1, entire energy is reflected back, so rho is equal to 1, alpha is equal to 0 and tau is equal to 0. Now we will see the laws of radiation. First law which governs the radiation, Stephan-Boltzmann's law. The law states that the emissive power of a black body is directly proportional to the fourth power of its absolute temperature. EB is equal to sigma T raised to 4, where sigma is known as Stephan-Boltzmann's constant and its value is 5.67 into 10 raised to minus 8 and its unit watt per meter square Kelvin raised to 4. The experimental evidence is already performed in our practical part. Second, Kirchhoff's law. The law states that at any temperature, the ratio of total emissive power E to the total absorptivity alpha is constant for all substances which are in thermal equilibrium with their environment. That is, epsilon is equal to alpha. Third law is Planck's law. According to the Planck's quantum argument, the spectral distribution of the radiation intensity of a black body is given by E lambda for a black body, that is given by 2 pi c square h lambda raised to minus pi divided by exponential ch upon lambda kt minus 1, where E lambda B is monochromatic emissive power of a black body, c is velocity of light, h is Planck's constant, lambda is wavelength, and k is Boltzmann constant and its value is 1.38 into 10 raised to minus 23 joule Kelvin. T is absolute temperature. Now we will discuss Wiens displacement law. Wien established a relationship between the temperature of a black body and the wavelength at which maximum value of monochromatic emissive power occurs. Definition of the Wiens displacement law. It states that the product of lambda max and temperature T is constant, that is lambda max into T is equal to constant and its value is 2900 mu mk. We know that E lambda, that is monochromatic emissive power of a black body, is given by C1 lambda raised to minus pi upon exponential C2 upon lambda t minus 1. So this is according to the Planck's law. Monochromatic emissive power becomes maximum when we derivate the above equation with respect to lambda and equate it to 0. So the above equation, now we are going to derivate with we are going to take the derivative with respect to lambda and equating it to 0. D E lambda by d lambda is equal to d by d lambda of C1 lambda raised to minus 5 upon exponential C2 upon lambda t minus 1. Using derivative principle, u upon v rule, u upon v, phi into u dash minus u into v dash upon v square. Just here u is c lambda raised to minus c1 lambda raised to minus 5 and v is exponential c2 upon lambda t minus 1. So just put the values as v and take the derivative of numerator c1 lambda raised to minus 5 minus u constant c1 lambda raised to minus 5 and derivative of v and divided by v square means exponential c2 lambda t minus 1 is bracket square. After getting the derivative, divide both sides by 5 into c1 lambda raised to minus 6. We get exponential c2 upon lambda t plus 1 upon 5 c2 1 upon lambda t exponential c2 upon lambda t is equal to 0. Solving this equation by trial and error, we get c2 upon lambda t is equal to c2 upon lambda max into t is equal to 4.965. So lambda max t is equal to c2 upon 4.965 C2 value is 1.439 into 10 raised to 4 divided by 4.965, you get 2900 mu mk. So Wiens displacement law is proved here, that is lambda max into T is constant. Thank you.